A bone mineral density test can be helpful in identifying the presence of osteoporosis. The result of the test is commonly measured as a z-score, which has a normal distribution with a mean of 0 and a standard deviation of 1. A randomly selected adult undergoes a bone density test. Find the probability that the result is a reading less than 1.27. So we're going to see now the application of how the study of the normal distribution can be applied in everyday life. This is the medical science application, and we are going to solve this problem. First off, you need to know a little bit about this disease, osteoporosis, right? This is a bone-related disease which is caused by the deficiency of bone minerals. We in our bones there is a deficiency of minerals, and that disease is caused. And this is the disease which causes the bone to get weak, and even so weak that when you bend or even you cough, your bones may be broken. Okay, and when you go for the test result is given to you as a z-score. So there is an application, right? And this has a normal distribution with a mean of a 0 and a standard deviation of 1. So we start from here. So we are going to attack this problem in step-by-step manner. Let's see the first step. What is the first step? Whenever I gave you a word problem in this chapter number 6, the normal distribution, a word problem you have, how you are going to attack this problem? Number 1, you're going to make a picture. You're going to make a diagram. Diagram will help you. So we're going to make a diagram. So first of all, you're going to make a bell-shaped curve. Here is a bell-shaped curve. Exactly in the middle, write the mean value. The mean is 0, and also indicate the standard deviation, which is 1. So if the mean is 0 and standard deviation of 1, this will be 1, this will be 2, and this will be 3. This is minus 1, this is minus 2, and this is minus 3. That's the first step. What is the first step? Draw a bell-shaped curve and indicate the mean and the standard deviation. The first step. The second step. In the second step, you are supposed to indicate the value of your interest. The value which I am interested in is this one, 1.27. This is the value I'm going to indicate, I'm going to locate on this graph. Let's see, where is this value? 1.27 will be somewhere here. I hope you understand that. And what you do once you have located this value, you build this wall, a wall like this. Once you have located this value, 1.27, you build a wall like this. By building this wall, this graph is divided into two portions, portion 1 and a portion 2. This entire graph, normal curve, is divided into two portions. Now you might be wondering why I numbered these two, why I numbered this graph 1 and 2. Why? Because I want to shade one of the portion. The portion, which portion I'm going to shade will be given to me by the problem. What the problem is saying: find the probability that the result is a reading less than, this is the word, keyword, less than 1.27. That's the keyword. All the values on this side are more than 1.27, and all the values on this side here are less than 1.27. So clearly we are going to shade this region. This is the region I'm going to shade. Right? So why I'm shading this region? What is the purpose of shading this region? The one I'm doing in green now. The purpose is I want to draw the attention of the students that this is the area which needs to be calculated. This is the area that needs to be calculated, area to be found. And remember, in this chapter, area is the same as probability. So this is the area I'm going to find out. And what is actually the problem is? The problem is I have to find the probability that the z value is less than or equal to 1.27. That's the probability problem I'm actually trying to solve. Now this probability can be found by a table by hand computation, or this can be done by using technology. I will show you both the steps, both the procedures. First, I will show you how you can find this value by using table. So our z-score is 1.2, and let me use a different color to draw your attention, and this is 7, 1.27. Right, so our z-score is 1.27. Let me go to the table. This is the table we have, and let me show you where is 1.27. Look at this one. My z-score, the z-score I'm interested in, let me write once again here, just for you recall, my z-score is 1.27. So what I'm going to do, I'm going to look at this 1.2 in this column. Here I'm going to look for 1.2. Here is 1.2. Here is 1.2. And I will look at 0.07 from here. So what I'm going to do, I'm going to go like this. Keep on going. And I'm going to go like this. At the intersection of these two is my desired number, is the number I'm looking for, 0.8980. This is at the intersection of these two, 1.2 and 0.07 is my required number, 0.8980. So our answer comes out to be the probability, or the area, which is the same as probability. Please recall that this is equal to 0.8980. I can also write this in percentage. So this is how you can do the percentage, 89.8%. So if I randomly select an adult, there is an 89.8% chance that his or her bone mineral density reading will be less than 1.27. That's how you're going to interpret this. It's very important that you interpret the result so that the other people understand what is going on here. Now let us use technology to solve the same problem, and the technology we are using is Microsoft Excel. How we're going to do that? Let's see. So we're going to go to the formulas, more functions, and a statistical function. Which function I'm interested in? This is norm.s.dist. Norm.s.dist. Let's find that function. Norm.s.dist. This is the function I'm looking for. This is the function. So what this function is saying to you is asking you, give me the z-score. Recall from the discussion, our z-score was 1.27. And now he is asking, are you looking for the cumulative area all the way from the left side to the boundary wall of that z-score? That is the meaning of the cumulative. This is important that you understand that. A lot of students have difficulty in understanding the cumulative. What does it mean? It means, are you interested the area all the way starting from the left side, all the way up to the starting from the left side, all the way to the boundary line of that z-score? Say, yes, I'm interested. So it's true. Yes, I'm interested from cumulative area. Now when you press OK, you will get this area. This the area or the probability. Let me write what the formula I have used. Formula text flying. You don't have to worry about this. What I'm doing here, I'm just trying to give you what the formula I have used. Norm.s.dist 1.27, 2. So in this way, you can solve this problem by using Microsoft Excel. Now let us see how we can solve this problem using StatCrunch. So I already launched the StatCrunch. What you're going to do, you're going to go to the stats, and you are going to go to the calculators, stat calculators, and in the list of these calculator, you're going to go to the normal distribution, normal, right? Let's understand what he is saying. Let's understand that what he is saying. You have to enter these values. What is the mean? Our mean is 0. And what is the standard deviation? Our standard deviation is 1. You know that because this is a standard normal curve, right? And what we are looking for, the probability when the z, here it is x, but when we have a standard normal curve, x value and the z value, they coincide, right? This x value will be the same as the z value. So we are looking for z is less than 1.27, right? Less than 1.27. And what we're going to do, we're going to hit compute, and you will see the answer comes 0.8979. When you round it to a 4 decimal places, it is 0.8980. And look at this StatCrunch, it also gives you the picture. That's the area, or that's the probability. That's what he was saying, all the way from the cumulative area from the left. Look at this red area which is shaded. This is 1.27, and this is the area, it's a cumulative area starting from the left side all the way up to this boundary line. That is what he was saying in Excel. Are you looking for the cumulative area? So what in that, when I was doing this Excel stuff, it was not all that clear what this is, but in this situation it is quite clear that cumulative area means you start all the way from the left side and go all the way up to the boundary line where the z-score is 1.27. So I hope you understand this problem, and we will see more problem in the next video.